Here's Startup Week. Everybody enjoying Startup Week? Maybe? No? Has anybody gone to any Startup Week events yet? Is this your first? 1, 2, 3? Who's startup? This is your first Startup Week event, which barely counts. Yeah. Who's here? Is this your first time to CHADEV? Anybody? Wonderful. That's good. This is great. All right. Welcome, welcome, welcome. So we're community run. Stuart here has been with us for, I don't know, for forever now. He works at Unum, and he's a senior software engineer there. And he's going to be talking to us today about, is it Selenium? Yeah. So this is going to be fun. If any of you out there would like to give a talk, we would love to have you do that, and you should come talk to me. We have dates available, I believe, in December right now, and if that doesn't work out for you, then we can also do a date in the new year. That's wide open. So without further ado, everybody give Stuart a warm round of applause.
Hey, thank you. Hey. Welcome to the 2016 presidential debates. Man, you can't buy that stuff. So anyway, thank you for coming out today. What I want to do today is talk to you about experiences that I've had with automated testing, especially using Selenium. So I've got some goals today, and I know some of you may have already used Selenium, but I hope I have something for everyone, whether you used it or not. So what we want to do is to learn what Selenium is, how to create an automated browser, where Selenium fits into the continuous integration loop, and how to scale Selenium. So let's get started. What exactly is Selenium? In real simple context, it's just this very simple API that allows you to write code to talk to a browser. So your code communicates to the browser via the API, and you write code that's going to mimic a bunch of user activity. Now, before we get into that, let's talk about where it came from. So if you didn't know this, Selenium was created all the way back in 2004. And the reason that's great to me is that it's like JavaScript. It's had a long time to mature, to evolve, to become stable, and to gather a lot of support within the community. Now, the guy who created it, Jim Hugens, he actually went to work for Google 3 years later. And of course, what does he do? He brings Selenium into Google. And as a result, you had all the folks that were working on the open source project, plus the backing of Google, to bring everything together into a single open source project. And that has really caused the project to be very well received, very mature. Just a little comment on the name. Where did Selenium come from? Well, Jim wrote an email to the project colleagues and said you can cure mercury poisoning by taking selenium supplements. And he was referring to their largest commercial competitor at the time. It was a company called Mercury Interactive. So, you know, Mercury was trying to kill their project, and he was like, well, you can cure mercury poisoning. That being said, the project has evolved to support almost every browser out there and almost every version of every browser. Some have been appreciated, but if you need to test in a browser today, you'll probably find a driver for it. But to me, the real strength of Selenium is that it's been ported to so many languages. And again, I'm going to say this over and over again, one of the strengths of Selenium is the fact that it's simple, it's got a very simple design, it's not heavy, it's lightweight, and it makes porting itself very easy to all these different programming platforms. So if you know a language, there's probably a WebDriver that runs on Selenium, And of course, it's on all the major platforms. So it really is truly an open source user community. I don't know if you ever go out to any of the GitHub sites to look at projects of software you might be working with, but you know, theirs just really impresses me. And one of the reasons it impresses me because in the single master project, you can see that you've got .NET, you've got Java, you've got JavaScript. Within JavaScript, you actually have a JavaScript and a Node implementation, and you've got Python, you've got Ruby. So everything is here. If you want to learn about Selenium for your language, you know, it's going to be here on the GitHub site. It comes in 3 offerings. there's an IDE, and that's pretty much your test recorder and playback tool. It's a Firefox plugin. I don't find it very useful. I find that the API, which is the heart of Selenium, is written so well and so simple that I rather go just directly right into the code and start writing my test. And you'll see that hopefully today. So the WebDriver is the heart. And then when your test suites start growing, you're going to want to scale them, and that's where Grid comes in. So goal 1, so now we all know what Selenium is, so let's see how it works. So what you do is you take the WebDriver, and you're going to create an instance of it. And when you do so, you tell it what browser you want it to communicate with, and you can pass any additional capabilities to it as well. Once you've done that, you navigate to a page, and once your page is displayed, you can manipulate the DOM. Once you've finished, then you just quit your instance. Now, it's that DOM manipulation that makes Selenium so powerful, and that's where you're able to find elements in almost any fashion possible. And if you're already like coding in JavaScript, it makes it very natural transition to start writing Selenium test. You can locate the desired element by ID, name, CSS, or Xpath, and that is in the order of how performant they are, with ID being fastest and Xpath being the slowest. Then you can perform any action on the element that you could do with any other type of DOM manipulation. You know, click a button, send keystrokes to a text box, or even set attributes on an element. And then once you've done that, you check the result of your action. So let's look at this. So I have created a little demo application. It's a little, I did it in Node. So can y'all see that okay? I need to zoom in. Zoom in a little more. Is that better? Okay. So I've created a couple of little Node modules, and each one's going to represent something. But here's one that's going to represent a little, very simple Selenium test. So up here, we're going to create an instance of our browser, and we're telling it, hey, you're going to be a Chrome browser. We'll navigate to a page. Then we're going to look for an element named search, which is going to be an input box, and then we're going to pass in Chattanooga to that. Then we're going to look for that element, and I'm having to look for this element by Xpath because it didn't have an ID or a name on it, and it's a button, and I want to click it. Then I'm going to do an explicit wait until the page changes and the title represents that text. So let's just run it real quickly, and I am doing this in Visual Studio Code, if you haven't used that yet. I added the sleeps so that the screens wouldn't flash by so fast that you couldn't see what was going on. Goes to the page, types in Chattanooga, presses the button. Now notice we've got some unwanted messages at the top. Chrome is complaining because I've got some dev extensions on and it doesn't like the URL. So with that, what we can do is we can actually set the capabilities. So up here, before we create our driver, we can define a Chrome capabilities object. And in it, we can pass some arguments that we want to pass to Chrome when it starts up. We want to tell it, hey, we're a test type, and disable extensions. Then, when we create our browser, all we have to do is, hey, we're a Chrome browser, and also, here are the capabilities that we want the browser to have. And just so you can see that it works different ways, I'm also searching for the button by a CSS selector this time. Again, this is a very simple test, but obviously it's just to demonstrate how it works. Some of you, when you start writing tests, will probably do more actions. But you can see our browser started with the messages being gone. Just one little note, too, about using the Node version. And by the way, I am using the WebDriver version 3, which is still in beta. Hopefully it will be released pretty soon. It's completely asynchronous, so that's why I need the promise to make the browser sleep for an extra 5 seconds after the action. So when you start testing with browsers and you specify the browser, Chrome is the fastest and the most lightweight. However, Selenium was originally created with Firefox. At the time, Firefox was the open source browser. Chrome wasn't even around in 2004. It came out later. So a lot of the Chrome functionality, Firefox functionality was actually built into Selenium. However, that's coming to an end because as Mozilla has evolved Firefox with this new Marionette driver, with version 3 of Selenium, and from version 47 of Firefox onward, you'll need a new Gecko driver from the Selenium website to run alongside your Selenium WebDriver. Internet Explorer, well, we can always thank Microsoft for making our lives more complicated. Where I work, we've implemented enterprise controls to set Internet Explorer settings that can't be removed even if you have administrative rights over the desktop. So sometimes those security settings will prevent Selenium to work. There are hacks to get it to work, but for the most part, just be aware that Internet Explorer is still hard to play with. And of course, now Microsoft has its new Edge browser. So they've created a new standalone driver. Guess what? They named it WebDriver. Thank you, Microsoft. Just make things more confusing. But currently, it only works with Selenium 3 and only for C# and JavaScript. Now, there are some gotchas when you start using the browsers. The biggest one is that browsers evolve faster than the grid and than Selenium does. So what you'll find is all of a sudden, you'll come in if you have automatic updates turned on your version of Firefox and you go to run your test, they fail. So be cautious of automatic updates, especially if you're going to be running a grid server or having Selenium run on a server. You probably want to remove the automatic update feature and have Selenium update your, as Selenium updates itself, then update the browser with it so it's simultaneous. Some WebDriver tips. These are just a few little things to make the WebDriver run just a little bit faster. One thing is to use only explicit waits if you can. It does have the ability to let you do an implicit wait for an extended amount of time, but it's going to wait that entire length of time. And if that element appears, you could go ahead and be acting on it. So that's why explicit waits are a little more performant. You can also pre-populate cookies. Now what that does for you, if you have a web page that needs a cookie that has been created, say maybe after a login page, well, now you have to go through the login page to get to the page that needs the cookie. You can preset your cookie and then go directly to that page if you're using cookies in that nature. So it's just a way to bypass some pages and make the tests run faster. You don't have to have images if you don't need them. So you can set up your browser so that it doesn't display images. In Chrome, you just create a separate profile and run Chrome with that profile. And you would do that when you set the capabilities of the Chrome driver and start it up. Another one, and this becomes more of an issue you have to deal with as our sites are getting more and more responsive. So if you're using Bootstrap or you're using Pure or something else, start your window maximized because that's going to be the place that you see all of your elements. If you don't start it fully maximized, it may go into responsive mode and all of a sudden some of your elements disappear, which will cause some of your tests to break. Also, your browser can only is limited by the size of the system it's on. So for example, if you're running, say, Linux and Firefox on Linux, your VNC session may only support a Firefox browser of 1024 by 768. So that might be a smaller browser and all of a sudden your menus disappear. So just something to watch out for. So now we know how to create and automate a browser. So one of the things that Selenium does for us is it really helps us strengthen our continuous integration and deployment loop. So after you build and after you do your initial execution of unit test and deploy, then you want to turn Selenium on and let Selenium actually validate the environment that you've deployed to. So no matter how well you think things are, until you deploy to an environment and actually run against that environment, you don't know how solid your system is or if any changes have impacted you. One of the great strengths of Selenium is that because it's been ported to almost any language, it can run alongside virtually any testing framework, your testing framework of choice. Since I'm using Node and JavaScript, I can use Mocha. Obviously, you could use TestNG, MS-Test, JUnit, or any other framework that you want to run in. It's based on your language of choice. And if you don't like it, you can always create your own. Again, because Selenium is compiled to your language, it makes it very, very flexible. So let's just see a test real quick. So here, I just have a very, very simple test. So here, I'm going to bring in the default assertion library that's built into Node called assert. You could use chai or something else, or should. But here, I'm just going to create my test. I'm going to add a few assertions, let it execute. And what you'll do is you'll create a suite of these, and you'll run them recursively on your system. And we'll do here, you can see it's going to call, you can see that mocha to kick off this test. If I go back to my output window, you can see here mocha ran through my test and all of my assertions passed. And now if you want to really see some test, I encourage you to download Selenium Master. And in it are Selenium test itself using Selenium. And there are tons and tons and tons of tests. Here I'm down into where the Node Selenium WebDriver is, and it's just an NPM application. So I can just say NPM run script. And it was really helpful for me because I could actually start looking at, run test. Because I could actually start, looking at some of the tests that were being executed and say, oh yeah, I'd love to see how that works. So here you'll just see it. And this is just basically, if you look at the run script, it's basically there's a folder out there with all the tests, and it's just saying, hey, recursively go through everything. They start passing. So it's just a really nice resource if you want to see Selenium at work by itself. Sure. So when you execute tests, of course, as you write them, you're going to execute them locally, but as your test suite grows, you're going to want to move that off to your CI server. I'm really biased and fond of Jenkins, but there's any CI server out there will pretty much have a plugin for Selenium, or it will have a plugin for whatever test framework you're using, and you can kick that off. Now, when you're running on a CI server, you'll need to most likely use a headless browser. Who's not familiar with a headless browser? Okay. A headless browser is a browser that runs in memory. It doesn't have a UI with it, so that way you can mimic browser activity without having a screen. However, if you run on your CI server, you're using the resources of your CI server when it should be doing other things, like doing other builds and other jobs. So what we're going to do is we're going to dispatch that over to a Selenium Grid, and that Selenium Grid, because browsers are very memory intensive, and you start launching tests, you want your test to run A, as quickly as possible, and B, to be as efficient as possible. So that's where the Grid is going to help us out. So that being said, we're going to go into what I call the really essence of Selenium, and that's the Selenium Grid. So the grid allows you to execute tests on different platforms, on different browsers at the same time. It allows you to run multiple tests at the same time, so you can reduce the time it takes for your test suite to complete. One thing that you want to achieve with your continuous integration loop is that you want feedback as fast as possible. So as soon as you recognize a failure, you want to be able to address that failure as quickly as possible. If you have a suite of 120 tests, you don't want them to take 6 to 7 hours to run. So that's where the grid is going to help you out a lot. So this is kind of a layout of how the grid works. There's really two components to it. There's a hub, and the hub is basically a dispatcher. So what your CI server is going to do, or your test framework is going to do, it's actually going to send the request to the hub, and then the hub is going to look for an available node. And it's going to say, okay, what operating system do you need? What browser do you need? Do I have one available? And then it's going to send that job to that node. And as you can see, you know, depending on your operating system will depend on the number of browsers that you can, the type of browser that you can execute from. So it's a very, very simple process to set one up. That's another great thing about the grid. They use that same philosophy. Let's keep this very lightweight. Let's keep it very simple. So let's just see how that gets set up really quickly. So here, I've got a Selenium folder, and it's got all of my drivers in it. So we're going to first look at setting up a hub. So when we set it up, we can pass in parameters. So we're going to put them into a JSON file. In here, let me just make that a little bigger. Yeah. So here I'm just going to say, okay, I'm going to be a hub. I'm going to be at 127.0.0.1, and I'm going to be running on port 4444, and some other settings to have to do with polling and performance. To start it, you're just going to start a jar file, and you're going to tell it, hey, I'm going to run as a hub. So we've got one jar file for both hub and node, and then I'm going to pass in my JSON file with my parameters. And oh, by the way, let's start a log. Let's put everything in this log file. Start it up. My hub's running. Over here. And here you can see I have a grid. Unfortunately, it doesn't have any nodes. So let's get a node added to it. Again, it's the same principle. Have a JSON file with our properties. And in this case, I'm going to tell it, okay, you're going to support Firefox and Chrome, and you can have up to 5 instances of each. And we're going to run on port 5555. And this is the hub we're going to talk to. So when the node starts up, it reaches out to the hub, registers itself, and then all of a sudden it's ready for jobs to come in. Here, if I go here and refresh, now you can see I have my node ready and waiting. So let's use it. Now it's really easy to use a grid. All you have to do is simply tell it the server that you want to use, and the driver automatically knows that it's running remotely. So this is going to be the same test. We're going to kick it off. Over here to my grid. See it start up in the background. Notice my Chrome little browser is grayed out because it's running the test in the background. And once it's finished, I release the driver. Now let's look at one other example, and this is kind of a nice little pattern I see quite often, and we actually implement it where we work. If you look at our test, really, all our test is doing is what's in this demo grid method. So it's basically navigating to a page, entering a search, and finding the search button, clicking it, and waiting for a page to stop. Now, what we want to do is we want to be able to run this against multiple browsers at the same time. So one way to do it is to then create wrapper methods based on your on the browser you want to use it with. So here we're going to create a Chrome driver, and then we're going to call the demo grid script. So we only have to have one copy of the test, and then we just wrap it and call it with that browser. So let's see that run real quick. Browser demo. Here's my grid. And there the node instances start. See, they both started simultaneously. See them running over here. Running Firefox. Finished. And both of my browsers have been released. By the way, if you didn't see that, just because I don't want to glance right through that, you want to run something in parallel. Oh, didn't want to run it, sorry. I'm not to have too many demo disasters. Let me just go to my package.json file. Over here on this line, if you can see it, it's the double ampersand that's letting us start the processes. So they're independent node processes, but the double ampersand allows us to kick them off and run in parallel. So you could actually have started a mocha process to recursively go through a folder. So you can have all your Chrome tests kick off and all your Firefox tests kick off, or however you want to segregate them. It's up to you. So there are a few gotchas when using the grid. One thing, and we're struggling with this, is there's no definitive documentation of like how many nodes should you add to a hub and how many grids should you put on a single server. You know, a lot of it, of course, there's the physical constraint of the server that you're running on, you know, based off CPUs and memory, but there's nothing really out there to tell you what's a good setup. What we are finding is that the hub can be a bottleneck, so you don't want to have a hub with 50 nodes on it because all that traffic is going to go through that one dispatcher. You probably want to have more hubs with fewer nodes, so maybe a 1:4, 1:6 ratio. Don't have too many instances of browsers on a node. So again, you have to experiment with that. And if any of you can find this documented somewhere, please send it to me. I'd love to see it. There's another thing that we see happen with nodes is that sometimes test will throw fatal exceptions. And even though the test framework is supposed to have that final cleanup method, some exceptions will just prevent that from running. And then what you get stuck with are browsers and nodes that have resources still left open. So one thing that we have found is we need to do a regular restart of our nodes. We try to schedule that nightly just to make sure that all the resources are cleaned up. Now, this is something that is your responsibility. So you got that grid out there, and it's got all these nodes and all these instances of browsers. But it's up to you to figure out how to structure your tests so that they can be run in parallel. And so some really good test writing tips is to make sure your tests are autonomous and atomic. So that means the test is really focused on a single thing, not a large test doing a bunch of things. And what this allows you to do is to take these autonomous tests and group them together, and then you can come up with multiple groups and then throw them at your grid at once. Because remember, you don't want that grid to just be executing your tests synchronously and taking 8 hours to run, we want to reduce that to maybe 30 minutes or 40 minutes, or even shorter. So how you do that is going to vary on the way you write tests, and also what your test framework can support. Some test frameworks can automatically kick off your test in parallel. However, you can't control the order of that, so that's another reason why it's important to make sure your test can be executed autonomously. Now, if you don't have the resources to set up your own grid, there are a ton of cloud providers out there. I think the most predominant is Sauce Labs, Browser Stack, which many of you probably use for your cross-browser testing. Now they're in the grid business, and it seems like just about everybody is getting into the grid business. There's also a Docker implementation, which I recently got to implement. There are open source containers. You can download, you can pull a hub. There's a Chrome node with one browser instance, and there's a Firefox node with one browser instance. And if you think about how the way Docker works, it's really, really efficient, because you won't have those issues with nodes and resources, because what you're going to do is you're going to write a bash script, because this runs on Linux, and you're going to say, hey, start a hub, start a node for Chrome, and start a node for Firefox or whatever. And then as soon as you finish running your test, you just have that bash script remove them. And because the containers are already loaded in memory, they start up in just a matter of like 1-2 seconds. They're very, very quick. And so it's a very efficient way to isolate your tests. Now, what I have personally found is that because you can run into issues with your node, to create 2 or 3 nodes to your hub with every test. So that way, if you do have a failure on a node, but you may be running 4 or 5 tests at once, you'll want a separate node to be available and working. And then finally, there is the folks at Groupon created this add-on called Selenium Grid Extras. So they were kind of frustrated that all the things and the gotchas that I've talked about couldn't be controlled by the grid itself. So they added this. It lays on top of the Selenium Grid, and it's open sourced, and it gives you the ability to restart a node after a set number of test executions. It gives you the ability to automatically upgrade WebDriver, which is something you really want to keep up to date, because again, keeping WebDriver up to date and your browsers up to date is very important, especially for security reasons. It gives you the ability to record tests, and when it's not like a test, record, and playback, but what it does, it can actually create a video image of your test that's running. So if you have that one test that you just can't figure out why it keeps failing, you could get the video image and see the playback of the test from that browser. You can take OS screenshots, and there are a lot more features. We've not installed it, but again, it's open sourced, it's out there, it's been around for several years. So now we know how to scale Selenium. There are other uses, because again, it doesn't have to be used just for testing. You can use it for website monitoring. There's a company out there called New Relic, which does all of their website monitoring using Selenium and Selenium grids. Any boring web-based administration task. You can also use it for performance testing. If you have the time and you have the resources, you could actually load up a grid with hundreds of nodes and have it actually hit your site all at once, which is more realistic than a test virtualization. And just some final thoughts. Some of you may like test writing. Many of you probably don't like test writing. So it's a great way to, learn another language. So like today, I don't get to work a lot with Node and ES6, so I had a lot of fun writing all my examples in Node and ES6. It's also great for novice developers. So if you have that novice developer on your team, if you really want to onboard them very quickly, let them start writing your Selenium tests. It gives them the ability to learn how you manage your code. It gives them the ability to learn your application, so they learn how it works. It gives them the ability to learn the language that they're working in. So it's a great starting point. And it's also, what we're finding is it's also, because the language is, the API is so simple to learn, you don't have to master the entire language. You just have to master the language enough to write your test. So you can actually start working with people that aren't as technical or don't have that technical background so that they can start writing Selenium tests. So some final thoughts. Any questions? Yeah. Yeah, he's going to bring a mic to you.
So something that I was thinking about using this for is I work on this project that like data is piped through as you navigate through the project, and if you want to test anything, even just manually, you have to follow this kind of circuitous route to that place. If I start a Selenium instance and then don't tell it to quit, will it leave the browser open with me kind of in charge?
Yeah, it leaves it open, leaves those resources out there in memory, whatever page that browser was on, whatever it's doing, it's going to keep doing. Or it may time itself out, but the browser may not close itself properly, and you will get memory leaks, especially on the grids.
Thanks.
Any other questions? Yeah.
When you're using the grid, how do you handle rolling back database changes? I mean, what's a typical approach to doing that?
So that goes back to more of your test writing philosophy, especially with functional tests. Often with functional tests, you have to set up the scenario you're testing, which can include adding data to a database, then running your test, and then removing that data. So that's not really something that's part of Selenium. That's part of you and how you write your test. Again, because you're using your testing framework, it should be responsible for the setup and the teardown, right? The API is just basically how you work with the browser. So just make sure that you handle that, any extra try catches you need so that you don't have those fatal exceptions preventing the teardown from occurring.
I mean, where would your instance be of your application typically? I mean, is it at a node level? Is it at a hub level? I mean, how does that work in that?
So the application's running through your browser, which is on the node, right? So, but it's just like any other browser. Maybe I'm not understanding your question, but it's the physical execution is on the node itself. That's where the browser is launched, and you can see it. In fact, that's one thing I didn't show. We can just look at that real quick. If I go back over here to the node log, reduce this just a little bit so we can see it. So you can see this was everything that the node was doing. And you get down here and you can see where, okay, here's where it's doing the navigation to the server. There's the get. There's where it's doing the find element. So everything's happening on your node. Yes?
If we're looking for we're currently using another testing tool. We're looking for something that's easy for us to develop without a lot of coding.
Mm-hmm.
I wanted to see the IDE portion of this, and what are your issues with the IDE?
Well, so it depends on what language you use. So this is using Visual Studio Code, but I could use any IDE that's used for JavaScript, like WebStorm or Atom or Sublime. I just happen to use this because I wanted to get some experience with it. Again, another example. If you're using Java, you're probably using Eclipse for your IDE. If you're using Visual Studio, if you're using C#, you're using Visual Studio for your IDE. So it just depends on the language that you're using. But obviously, you want to use the language that you're the most comfortable with. And I can have a system written in one language, but my test can be in another, just because the IDE is ported to everything. You could write them in Python.
When you say IDE, you're referring to the
Development environment.
Development environment
Yeah.
of the language.
Yeah.
So there's not really any other way to develop.
There's the recorder. There's the IDE, which is the the record and playback option. That's a Firefox plugin. I removed it because I don't find it to be very flexible. I don't find it to be very functional. Now there are a lot of plugins that extensions you can add to the plugin, but I just find that I can go in. I know what I want to do on my website. I can actually write the code faster than doing the playback, going into the recorded file, and making any adjustments. Any other questions?
Does it have any mobile rendering kind of?
Yes. Yeah. So if you actually can go out to the project, you can see where it's got capabilities to support Android and iOS. Yeah, I encourage you, if you want to just go look at a really nice open source project, again, the Selenium Masters, really, it's a fun place to go. Anything else? Well, thank you. I appreciate your time.
Thanks for coming out this week, ladies and gentlemen. We'll be back next week. See you then.